Hi, my name is Jennifer, and in this video, I'm going to show you how to divide rational expressions. So grab a pencil and some paper and work through these examples with me. Take a look at our first example. We have 10 times x minus 3 over 7 divided by x minus 3 over 21. When we're dividing rational expressions, we're actually not going to divide, but we're going to convert these to a multiplication problem. And here's how we're going to do it. We are going to keep the first rational expression the same. We're going to change our division sign to a multiplication sign. And then we're going to flip the second fraction or find the reciprocal of this fraction. So let's go ahead and rewrite this problem as a multiplication problem. The first rational expression, it's going to stay the same. Our division sign will change to multiply. And our x minus 3 over 21, we're going to put down the reciprocal, which really that just means we're going to switch the denominator with the numerator. So instead of 21 in the denominator, 21 will be in the numerator over x minus 3. Once we have it rewritten as a multiplication problem, we're going to follow through our multiplication steps. We're going to look at each of these terms and see if there's any way we can factor them anymore, which we can't on this problem. So we're actually ready to go ahead and simplify. Notice that we have a binomial x minus 3, and we have the same binomial x minus 3 in the denominator. Because they're the same, we can cancel those out. And that leaves a 1 where those x minus 3's were. Next, notice the numbers that we have left. We have a 10 and a 7 and a 21. The 10 and the 7, they do not have anything in common, so we cannot cancel these two. But because the 21 is in the numerator and the 7 is in the denominator, we can simplify those by dividing out a 7. 21 divided by 7 is a 3. 7 divided by 7 is a 1. So let's figure out what we have left. We still have this 10 left. And then we have this 1. We have a 3 over here in that numerator, a 1 in this denominator, and a 1 in that denominator. So this now looks like 10 times 1, which is 10, over 1, times 3 over 1. 10 times 3 is 30. 1 times 1 is 1. So for this problem, our answer is 30 over 1, or just simply 30. Okay, let's look at another example. We have x squared minus x minus 2 over x plus 2 divided by x minus 2 quantity squared. Now, instead of dividing rational expressions, the easiest thing to do is to convert each of them to a multiplication problem. So here's what we're going to do. We're going to keep the first expression exactly the same. We will change the division problem to multiplication. And we'll take the second expression and we'll write the reciprocal. In other words, we'll take what was in the denominator, put it in the numerator, and then what was in the numerator, we'll put it in the denominator. Now before we get started, notice that this one, it doesn't have a denominator. So anytime you have a number or an expression that doesn't have an obvious denominator, we can always just put it over 1. Okay, now we're ready to get started. Let's go ahead and rewrite the problem as a multiplication problem. We have the first fraction stays the same, times the reciprocal of the second. So we'll put the 1 in the numerator and the x minus 2 quantity square goes in the denominator. Next, before we multiply straight across, let's see if there's any possible way we could cancel some of this. Before we cancel, it looks like we're going to have to factor a few things. Because remember, we can only cancel an x plus 2 if we have the exact match on the top. Right now, we don't have any of them that exactly match, so we're going to rewrite this trinomial, and we'll rewrite this quantity squared to see if we have any binomials that match. X squared minus x minus 2 factors into x minus 2 times x plus 1 over x plus 2 times 1. And when we have x minus 2 quantity squared, that just means x minus 2 is written down twice. Okay, now that we have everything factored, we're ready to see if we can cancel anything. Notice that we have an x minus 2 in the numerator, and we have the exact binomial x minus 2 in the denominator. So we can cancel one of those. Next, we do have an x plus 1 in the numerator, but we do not have that exact binomial in either of the denominators, so we cannot cancel that. Same goes with the x plus 2 and the x minus 2. We do not have the exact binomial in the numerator, so we cannot cancel those either. So I think we're ready to find out our answer. We are left with this x plus 1 times 1, and we're left with this x plus 2 and this x minus 2. So our final answer will be x plus 1 times 1, which is x plus 1, over x plus 2 times x minus 2, which we can just keep in two separate parentheses. So our final answer is x plus 1 over x plus 2 times x minus 2. Okay, let's try one more problem together. We have x plus 6 over x minus 4 divided by x squared plus 9x plus 18 over x squared minus 3x minus 4. Okay, let's get started. In order to divide rational expressions, we need to first change this to a multiplication problem. We're going to keep the first expression the same. We'll change the division sign to a multiplication sign. And then we'll write the reciprocal of this fraction, which means we'll switch the numerator with the denominator. So let's go ahead and rewrite this problem. Okay, before we multiply straight across, we need to first see if there's any way we could factor some of these parts of the problem. The x plus 6 and the x minus 4, there's really nothing we can factor, so that part's going to stay the same. But let's take a look at these trinomials. Remember, we can't cancel the x squared with this x squared because it's part of a trinomial. So unless it's the same trinomial over the same trinomial, there's nothing we can do until we factor this problem. So take a look at x squared minus 3x minus 4. We'll draw two sets of parentheses and write down x and x. Now we need two numbers that multiply to negative 4 but add to negative 3. and that's going to be a negative 4 and a positive 1. Okay, let's look at the denominator. We have x squared plus 9x plus 18. We need two numbers that are going to multiply to 18 and add to positive 9. Those two numbers will be a positive 3 and a positive 6. Now that we've factored everything into binomials, we're ready to look to see if there's anything we can cancel. In this numerator, we have an x plus 6. We have a matching x plus 6 in a denominator. So we can cancel these two and leave behind a 1. Let's see what we can cancel next. We have an x minus 4 in the numerator, and we have a matching x minus 4 in the denominator. So we can cancel those two terms, leaving behind 1s. We do have a binomial x plus 1, but there is not a matching x plus 1 in either denominator. And same with the x plus 3, there's not a matching binomial in either numerator. So we cannot cancel these two binomials. So for our final answer, we have a 1 times 1 times x plus 1, which is simply x plus 1. And you can drop the parentheses, over 1 times x plus 3 times 1. And again, you can drop the parentheses again. So our final answer to this problem is x plus 1 over x plus 3. Now, if you have any questions about this topic, please stop by your professor's office or go by the Math Tutoring Lab or watch this video again.